Okay, let's have a look here. The total cost, CX, in hundreds of dollars to produce X jars of mayonnaise is given by that formula. Calculate the average cost per jar over the following intervals. Is that similar to this one, isn't it? Um, yeah, it kind of is, isn't it? We can just make some changes here. So uh, these is a jar quantity 1, jars 2. Uh, oh, it's kind of weird because you can't really produce less than 1 jar. Oh, yeah. I'm not too keen on it. Okay. Um, D minus C. Okay. So it equals 0.00003 times x cubed plus 4x plus 300. And then what are we looking for? Average cost per jar. So that's called the marginal cost. It's like about 4. This doesn't this doesn't make sense. The total cost in hundreds of dollars to produce X jars of mayonnaise is given by that. So this is in hundreds of dollars. Calculate the average cost per jar over the following intervals. That's weird. $400 to produce a jar of mayonnaise? Surely that can't be right. To produce X jars of mayonnaise. Do I have anything wrong here? I I'm missing a zero. 0, 0, 0, 0, 0. $400 to produce a jar of mayonnaise? I kind of feel like they shouldn't have said about the hundreds of dollars in the text. 400 US dollars per jar, um, marginally at 100. That does not seem right. Use your answer from A to estimate the average cost to produce 100 jars of mayonnaise. Well, that's 703. But did I mean 100 additional jars of mayonnaise? The total cost in hundreds of dollars to produce X jars of mayonnaise is given by that formula. Calculate the average cost per jar over the following intervals. Okay, so it's not really marginal then. Average cost per jar. But over the following intervals. Oh, so I'm not sure that they mean this, or maybe they mean this, but divided by 100. So it's either going to be that or that. So the $4 answer makes more sense. So I think the English here is a little bit unclear. Calculate the average cost per jar. When production is in the following ranges. I think that would be a little bit clearer. Per jar when production is in the following ranges. Yeah, that's how I would phrase it. So I'll go with $4.09 instead of $409. That makes much more sense. Use your answer from A to estimate the average cost to produce 100 jars. Okay, well, that's just going to be 409. Yeah, so I don't think these are right. Let's read them out. She'll make you red. And she'll make you green. Green, I guess. A better green. No, a better green. That's a lime. Yeah, it'll do. Yeah. Okay. Calculate the average cost per jar when production is in the following ranges. Not marginal. Yeah. Okay. I'm happy now with that. Well, kind of happy. Right. For the following functions, use the graphing calculator to graph f. Zoom in to approximate the two values of a for which the derivative. Okay, so yeah, I'm going to use trusty derive because I just like it more than maxima. I think I can finish with this spreadsheet. No more. Yeah, it doesn't come up again. So let's close this. All right. Oops. Closing this. Okay. We have y equals x cubed plus minus 2x squared minus 11x plus 12. Ow. Let's try that again. Y equals x cubed minus 2x squared minus 11x plus 12. X cubed minus 2x squared minus 11x plus 12. Graph it. Easy peasy. Zoom out a bit. Right, and then zoom in to find the two values when the derivative is 0. Two values of x. Well, you can see here, looks like at about 8.3 and no, that's not, sorry, what am I saying? That's about minus 4/3, I'm guessing. And okay, so I would say about 2.7 and minus 1.36. Let's write that down. 2.7 and minus, what did I say? 1.36, or what would I say 2.7 and minus 1.4, roughly. That is for 49. We should have an answer at the back. Let's have a look. For 49. Okay. Minus 1.361. Okay, correct to two significant figures, and 2.7. Yeah, correct to two significant figures. Correct to two significant figures. All right. Let's see what's next now. Same again. Same again. Okay. Let's clear this up. Right. Y equals x over 1 plus x squared. So looks like about, that's got to be 0.5 and minus 0.5. So we'll say 0.5 and minus 0.5. Okay. 51. Suppose that NX computes the number of gallons of gas used by a vehicle traveling X miles. Suppose the vehicle gets 30 miles per gallon. Write a mathematical expression for NX. Okay, so NX is the number of gallons of gasoline used by a vehicle traveling X miles, and it's 30 miles per gallon. So 1 mile equals 30 gallons. So X miles would equal 30x gallons. So it would seem like NX equals 30x. I did all right. 30 miles. Oh, 30 miles to gallon. No, that would be yeah, not 30 gallons to the mile. Right, 30 miles equals 1 gallon. So that means 1 mile will be 1/30th of a gallon. So x miles would equal x over 30 gallons. So NX would be x over 30. Okay. What is N 100? How much gasoline used for 100 miles? So that's 3.3 recurring gallons needed for 100 miles. Okay, and then C is n derivative 100. N derivative 100 being the slope, the coefficient of x, 1 over 30. That is the rate. The 100 is actually not important here. It's the rate at which gas is consumed per extra mile beyond 100, or at 100 perhaps I should say. But that's actually not important really. The 100 part I mean. Let's see if we're right for 51. Yep, spot on. Okay, excellent. How are we doing for time? Yep, okay, we should get these finished. For that function, do the following: graph it, and then use the derivative function to find the derivative at the following points. Okie dokie. So it's x power 4 minus 5x squared plus 4 Okay, oh well, let's not get the derivative yet. Let's graph it. Great. And then what do we want? The derivative. At minus 2. Whoops. Okay, derivative at minus 2. Minus a half. Should have simplified it. Hang on. Minus 2. Minus a half. 1.7 and 2.718. Keep forgetting to hit the simplify button. 1.7 and 2.718. Okay, maybe we should approximate these. I don't have my calculator, but I know the button they're talking about. In the software, it actually calculates the derivative and then subs the value in. Your calculator won't do this. So in other words, your calculator won't display line number 3. It'll just display the numerical outputs. So I'll just delete line number 3 because you won't actually see it on the calculator. So you'll type in the function and the derivative and specify the point, and you should get these 4 answers. Okay. And same again for the last one here. Okay. X squared over x squared plus 1. Interesting graph. Oops, let's get the derivative. And let's actually make a function called n deriv x is equal to line 3. And then that way we can calculate a little bit quicker. So we have n deriv of -4. Simplify, approximate. N deriv of -2. Simplify, approximate. N deriv of 2 and 4. I don't like that weird symbol at the end. Oops. Two and 4. Okay. Right, so there are our 4 answers. Let's check the answer for 53. Yep, 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 and yep, they have it. It's weird, they have this one to 2 significant figures, but earlier they had this one to 4 significant figures. So it's a bit inconsistent here, especially since the questions don't specify the number of significant figures. But oh well, doesn't matter. We got to the end of the exercise now. So that is 3.1 completed. Success. Okay, and what do we have in store for the next time in 3.2? Calculating the derivative. Okay. And yeah, okay, we'll have a look at that next time. This looks very, I'm guessing that this is going to be the limit as h goes to 0, which I thought we used already. Maybe I was using that too early. Use the definition of A65. A65. Where is that? That's A65. Well, we can have a look at it. We can have a look at it next time. I was just a bit curious. Oh well. Oh, A60. Okay. I feel like there should have. Oh, that's 65. It's. Silly me. That's question 65. Oh dear. Okay. Embarrassing. Use the definition of a derivative to find f derivative. Yeah. Okay. Okay. That was silly. Right. Fine. Fine. Enough embarrassment now. We'll leave it for there for today. Any problems, please let me know. Thanks for watching, and I'll see you all next time.